Hello everybody, welcome on back to another coding tutorial, Python coding tutorial. We're going to be coding in Python. Python is the language we'll be coding in. I'm Perd Happily. Okay, many of you probably don't even know that I do coding tutorials or did coding tutorials, but now that I am back out of school and not coding every day, I can feel good and happy about doing coding tutorials for you guys again. So if you haven't caught up with the series, that's okay. This video will help to explain some stuff in it, but I do really highly recommend you check out the playlist and watch all the videos from the beginning because it is a step-by-step tutorial series. It gets more complex as time goes on. We're just kind of doing a review program today, and it'll be a very interesting little review program today. We're going to be making a encryptor and decryptor. So essentially it's, I'm sure you've heard of cryptography, or sending cryptic messages and then being able to decode them. It's insanely important in real life to have encryption. Your bank account, your credit card, whenever you do something with your credit card online, that information is being encrypted and not stored as plain text, because a hacker can easily get into it and then know exactly your credit card number, your bank account, etc., etc. So we're going to it's a really simple encryption and decryption code. It's nothing that you'll ever see in a real life setting, but it's a basic example that helps to do a little bit of review of what we've been doing in the series. So let's hop right in. I do want to show you that we now have a really nice thing. The screen may look a little bit funky. There's a weird gray bar in the middle of it. There's a reason for that. We can run the code, and now I have the code showing up, what the result of the code is right over in the bottom right. So now whatever I type, you know what is going on with it. Pretty valuable, pretty useful for you, so that you can see exactly what I'm doing at any given moment. So, we're going to talk about some unique topics today, one of which is a little bit more complicated than others. We're going to talk about the ASCII table, and I'm just going to put the ASCII table up on the screen right here. This is actually a little bit larger version of the ASCII table. Let me get the entire thing on here. There you go. That's the entire ASCII table. There's a lot of different stuff. You're probably like, Tyler, what the hell is this? So when your computer stores anything, it's working in zeros and ones, binary. You probably know this, but you don't know a lot about it, which is why we're going to do a video on binary, I think in the next coding tutorial. But everything your computer does is in zeros and ones. So if we're storing an A somewhere on our computer, that A is being stored as zeros and ones. And frankly, if it's a capital A, then it's being stored as 0100 and then 0001. That's exactly what a capital A is, because it's also 0x41 in hexadecimal. And we're going to go over hexadecimal and binary in another video, but for now, just realize that numbers, letters, anything is being stored as zeros and ones in your computer. So as you can see here, I'm going to zoom in on our ASCII table now, so we can see it a little bit better. If we look at capital A, you can see that capital A has a decimal value of 65. So ASCII is a character set. And what a character set is, it's essentially all of the characters that you can type and use on your computer. They're assigned to a certain value, and that allows them to be compared between each other and to pull those values in and work with them in your code. So that's exactly what we're going to do today. We're going to encrypt a sentence by converting the letters in our sentence to its ASCII value, and then manipulating that ASCII value to form something different is kind of what we're gonna do. So let's hop right in and let's do a little bit of coding, and we'll probably refer to the ASCII table again here soon. So we're gonna make three functions today. We're going to do a encrypt function, and we're going to pass in a sentence to encrypt. We're gonna do a function of decrypt. So we're gonna have a decrypt, and we're gonna have we're gonna pass in the result of encrypt, so we'll just do result right there. And then finally, we just have our main function, which we are going to use to get a sentence from the user. So I'm just going to put in a pass here. This just means we're not doing anything with them. Allows there to not be errors right now. We'll remove the pass here shortly. So then in our main, we're going to get input from our user. We're going to say that our sentence, we'll say here, we'll say S. S is equal to the input and then we'll say, you know, input a sentence that you want encrypted. Okay, so that's good. We'll be able to input a sentence, and then we're going to call encrypt on that sentence. So this is going to pass our sentence over to encrypt to then be used. And we can test this if you would like to for sure see that it is working the way that we wanted to. We'll add in our main call here at the bottom so that it does main when we run our code. And then we'll just put in encrypt to print our sentence. Okay, and we'll see that this is passing correctly. So you can see I'm typing input the sentence that you want. I would like to input in hello. Okay, so realistically, when we type hello, we've inputted it. Now it's going to send hello to encrypt, and encrypt is going to say, okay, you passed in hello, then let's print out hello, because that is our sentence. We do that, and it spews back hello. Quite good. Everything is working according to plan. Let's continue working here, and we're going to work in our encrypt function. Really, that's all we need in our main, is to say, hey, what do you want to encrypt? Okay, so now let's work in our encrypt function. So what do we want to exactly do here? We want to convert every letter in our sentence to its ASCII value, and then we want to do something to that number and store it back in something, and that's going to be our encrypted message. So let's just go over a really useful function. We're going to go over two useful functions, the ORD function and the char function, CHR. So what these two do is the ORD function will convert a character to its ASCII value. Pretty useful. And this is the exact opposite. It will convert a value to an ASCII character. Okay, and we can see this in action right now. So if I were to define a character, we'll call it character 1, and we will make character 1 capital A. Okay, if we print out the ORD of our character, character 1, which is a capital A, and print out the char of capital A. I mean, that's just going to be capital A, so it doesn't really work here. Let's do something a little bit different. Let's print out, we'll start by printing out this. Okay, we can run this, and we can say that, okay, hello, beautiful. And then it prints out the ORD of capital A, which is 65. And if we look at our ASCII table, you can see that A is 65. So that is working exactly according to plan. It's pulling that decimal value of A from the ASCII table. So then we can come back and we can say, okay, let's store in our value A the ORD of character 1. Okay, and then let's print out the char of A. So this is going to be the character of the ORD of capital A. Okay, so it's passing in 65. It's going to do the character of 65. And if we were to print that out, then you will see shortly, we can type in hello again in our thing here. You'll see shortly that this is going to print out a capital A because we got the character of 65, which we know is capital A. So we're going to be able to utilize these two functions to do a bunch of good stuff for us. So I'm going to start by, I'm going to define a empty list because we're going to store all the stuff that we encrypt in a list. And if you don't know about lists, and if you don't know about anything going on, then please go back and watch the first couple of videos. They will help you a lot more. And then we do a simple for loop because we want to loop through every character in our sentence. So let's do for letter in sentence. Okay, for each letter in the sentence, I would like to create a variable that is the ORD of that letter, and then we're going to just do something to it. This is where we're doing our encryption key, I suppose is what you can call it here. I'm going to subtract 20. I think subtracting 20 is a good plan. You could subtract any number you want. You could do minus 200. You could do minus 2,000. You could do minus 20,000. It doesn't matter. You just have to stay consistent between your encryptor and your decryptor, and I'll show exactly what this is doing shortly. Then we can say, okay, so our result is our empty list. Let's append whatever this L is that we just created to our list. So then what is this going to do? Well, I'm going to show you right now what that's going to do. We're going to print out our result here, and we're going to run this. So what happens when we do hello? Okay, we're going to type hello. We're going to do it, and here we go. We have 84, 81, 88, 88, 91. That's what our code is currently saying. You're probably like, Tyler, I got no freaking clue what that means. Okay, that's okay. So I typed in lowercase h, lowercase e, lowercase l, lowercase o. Let's look at the ASCII values of those. Okay, so we have over here is lowercase h is 104. Okay, so when we do our for loop, let's jump back to our for loop. We have, so for letter in sentence, is going to pull the h first. Okay, and it's going to say, okay, we have an h. So the ord of lowercase h is 104. And it's going to say, okay, do 104 minus 20. And 104 minus 20 is obviously 84. Simple math. And it's going to store 84 in L here. And then we're going to say, okay, so append to our list that L, which is 84. And as you can see in our list, our very first thing here is 84. So it worked properly. And we can check this for all of them. You know, lowercase e is going to be 101. 101 minus 20 is 81. It gets appended to our list. It gets put at the end of our list, and 81 is right there. Just going by basic logic, we would know that L, lowercase l, is going to be 108, because 108 minus 20 is 88. We have two of them, double 88s here, as you can see right there. And then finally 91. So we know this is working according to plan, and that's awesome, because now we can print out our actual encrypted message, which is great. I'll be right back. Okay, I'm back. Sorry, I have food delivered to my apartment. Had to make sure that I actually went and got it, because I do enjoy food. Let's print out the numbers from our list here. And this is going to require us to use some unique printing stuff here. So what you can do with printing, we obviously know that you can just put in something to print it, as we did above. And we're going to get rid of this one right here. But what we can do is we can specify to not end it with a new line. Okay, we can say don't end it with a new line, and then we can say down here print a space, and then don't end it with a new line. Okay, so what is this going to do? Let's walk it through before we actually show it. So we have our result, which is going to be the list of all of our numbers. That's what we have down here. So it has 84, 81, 88, 88, 91. It's going to say, so for the numbers in our result, so it's going to pull first 84. It's going to say print that number, but then don't do a new line. So it's going to print the number, and it'll be nothing. Then it's going to say, okay, print a space after the number, and then it's going to loop. And it's going to grab the next number. It's going to grab 81 here. We grab 81, prints that, doesn't do a new line, puts a space. So essentially what this is going to do is going to print out our numbers. And we can see that right now. Do hello, and we can see that our encrypted message is 84, 81, 88, 88, 91. Fantastic. We can actually make this look even prettier and say, print, this is your encrypted message. Okay, it's beautiful. And then we can come here and we can say, okay, type hello, and you'll see that our encrypted message is 84, 81, blah, 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 blah. This will work for a whole multitude of things. I can say this is the best encrypted message ever! Triple exclamation point. Shows I'm excited. And then we can hit enter, and you'll see we have a crap load of characters. We have a crap load of numbers in our list here. Look at all of them. There's an insane amount of them. Because it's a long message. Each letter, each character, even the spaces are being stored in here. It's 12. Because 32 is the ASCII value for a space. So it's pretty interesting how we have this. So that's really all we have for the encrypt function. We've encrypted our message. So now we got to decrypt. So let's call decrypt, and we're going to send in result here. We're going to send in our list of numbers. And essentially, the decryptor is the opposite of the encryptor. I mean, I think that's pretty straightforward to say. Let's create a new result. We're just going to say end string. Okay, we're going to call it end string. And we're going to make end string empty to start. It's just going to help us cut out. We can store it in a list as well, but it'll cut out the middleman of us doing that weird print. We can just print our string at the end here. And we're going to do the exact same thing as above. So for the letters in result, and I suppose we could even say for the numbers in result, because right now they're numbers, I want you to grab the letter. I want you to grab the int of the number, because right now it's a string in there. I want you to grab the int of that number. I'll convert it to an integer. And then I want to take that int, and I want to add whatever our number is up here, and I have to scroll this down for you, and I will do that as such. Please scroll, would you please scroll down for me? Thank you very much. We'll stick down here for right now. Gotta take the int to the number. Then we gotta add whatever the number was up here. So up here we have 20. We're subtracting 20. So down here we gotta add 20. And if we do minus 200, then we gotta add 200 down here. And that's still gonna work. It's all good. So then what else? Well, we now have it in number form. We have it back to the number that it's supposed to be. But we're not looking for numbers. We're looking for the letter, the character that's at that spot. So then we have to do our character function. We'll just say that L is equal to the character of L. And that's going to store it as a character now, which is great. And then we can just say, you know, our end string, do our end string plus that letter. And realistically, this is all we need. And we can say, print out our decrypted message. Your decrypted, not descripted, your decrypted message is, and then we can say, print our decrypted message, which is end string. And we'll just make sure that we put a new line over here, or else it's going to look a little funky. So then let's run this, and we can say hello. And it's going to say, this is your encrypted message, -96, -99. We switched it to 200, so it's going to look a little different. Blah, 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 blah. But your decrypted message is hello. So we know it worked, because we're not just, you know, printing out whatever we inputted. We're printing out the decryption of the encryption. You know, never do we see this original sentence in our decrypt. When we're printing, it's absolutely the encrypted message. So we know that everything's working. And that's an awesome feeling. We can do anything here. We can say, Tyler sucks at the Binding of Isaac. Okay? Decrypt that message for me. Look at that. Look at all the negatives. They're everywhere. -168 in there. That's a big ass number. Your decrypted message is Tyler sucks at the Binding of Isaac. It works. So this is basically how encryption and decryption works, except 20 times the difficulty here. They're going to be multiplying and dividing and changing things and changing this and that, because something like this is really easy to crack. You know, if somebody sees a pattern and sees, okay, well, when it was hello, those two middle L's, those two middle numbers are the same. So what word, if this is in ASCII, what word could that possibly be? And they could backtrace and figure out, okay, so if those are L's, then maybe you're just subtracting 200. So then if I subtract 200 from everything else, oh, look, it says hello. You know, and in a situation like a bank account or something like that, that's incredibly dangerous, because if they can figure out what the pattern is, then it's all for nothing. They have the decrypted stuff, and that's not what you want. So as a security person, I deal with encryption kind of stuff all the time. You know, it's very valuable to learn what encryption is, what it means, stuff like that. And this is just a very basic program to do that encryption. I realized that this went a little bit lower here. I can move this down. I just printed out the end screen. It's nothing too complicated there. But it works. It works very, very well. That is exactly what we're doing there. That's it. Pretty straightforward. If you didn't understand anything that was in this video, please let me know. Leave a comment. Ask questions. You know, I highly recommend that you guys write your own code. Go download Python. Write your own code. Because you're never going to learn to code by just watching. You got to actually type what I'm typing and then mess around with it. Make some changes. Instead of 200, do 2000. See what the difference is. Pull up your ASCII table. Play around with your ASCII table. See what you can do with it. You know, there's all kinds of fun stuff that you can do. We can make an even harder encryption program that does multiplication and division and properly can decrypt by sending it in numbers or something. We can do all kinds of wacky stuff. But that's going to do it for today's video. Next episode, we're going to be talking about binary and hexadecimal, which I am not excited to record because it is going to be quite difficult for me to record. But it's important to know, and I think you guys are going to enjoy it a lot. So that's the coding series. It's going to release every Sunday for the short time being. Hopefully you guys enjoy. If you did, remember to leave a like, comment, subscribe. Let me know what you guys did. Ask questions. For the love of God, ask questions. And I'll see you guys in the next video. Bye-bye.